So as seen from the title, this video here is designed specifically for those who is opting for additional mathematics as well as A-level mathematics. So if you are looking for the version for mathematics alone, I have a link at the right hand corner. You can click onto it and watch that first. So for those who stay here, if you are yet to watch the basic, feel free to click on the link as well, because that will build a foundation for you to better understand what I'm going to cover here. So without further ado, let's get started. The first major difference between Maths version and additional mathematics and A-levels version is that instead of giving you degree alone, they can now give you pi, which we call it radian. So you're required to learn this basic where you convert degree to pi. This is just additional knowledge. You're not compulsory to know this, but it's always better if sometimes the radian given for the range is very confusing. You're able to learn how do you convert it so you can understand the range better and better identify the answer will appear at which quadrant. So over here we have from degree convert to radian. So 90 degree, for it to become radian, we are multiplying it with pi over 180. So it will be 1 over 2 pi, or you can write it as pi over 2. Another example here, we have 270 degree. When you want to convert it into radian, same steps, multiply it with pi over 180, then you will get 3 over 2 pi or 3 pi over 2. So over here will be the most common application where we actually multiply 180 over pi to convert radian back into degree. Because sometimes the range given by the question, after the adjustment according to each and specific question, the range might look slightly confusing. So by you doing this extra step, converting the results back into degree, it will help you to better identify the range. So let's say we have an example here that goes by 6 pi over 8. Multiply it with 180 over pi, then you'll be able to get it as 135 degree. As well as 9 over 5 pi here, when you multiply it with 180 over pi, then you will get your final results as 324. So the core concept here is no difference with the mathematics, where you learn that your first quadrant is A, second quadrant is S, third quadrant is T, fourth quadrant is C. So A stands for all sine, cosine, tangent is positive. S as the initial illustrated, sine positive only. T, tangent positive only. And C, cosine positive only. So to make you remember this easier, the short form for this that I made up is all school teacher crazy. So I hope that you'll be able to memorize this. Moving on to the next slide, it's very similar to what we did earlier. However, it's just to show you the range. So it always starts from this red line here. That's why the first quadrant is there. Over the right hand side, it will be 0 degree or just 0 radian. So moving up to the center, we have 1 over 2 pi, followed by second quadrant, then pi. Third quadrant, 3 over 2 pi, and the fourth one, you will get 2 pi. So do double check the range, because this is an important step before you deciding what to fill up as your final answer. So next, we have the core formula that we'll be using for this topic. Over at the top, they are labeled in the blue star symbol. All this will be given in your exam paper. However, for those that are labeled in red color diamond shape here, this won't be given and you are required to memorize them. So I attached some of the example here just to illustrate the variation on the blue color star symbol formula given to us. So why are we using all this formula here? So in quadrant topic, there's actually two parts of the question. So the first part will be covering you proving certain equation set out by the question. So you're required to run some adjustment, reconfiguration and substitution just to prove that maybe A equals to B. So it might sound a little bit confusing here, but no worries. I will make another video specifically explaining on this part. So without further ado, I'm going to discuss 4 types of questions to help you strengthen your understanding on this topic. So over at example 1, so we have cosec theta equals to -2, and they gave us a range of 0 to 360. So I hope you noticed this. Our calculator can't actually key in cosec here. So you're required to use the formula table that you gotten earlier and convert this cosec into 1 over sine. So I ran the cross multiply method and I got the -2 sine theta equals to 1. After the adjustment, I got the sine theta equals to -1 over 2. So this step is where I stop and double check where would my answer appear, at which quadrant sine would actually be negative. So I want you to think it now, okay? Then later you double check whether your thoughts is it same as mine. So I move on and then key in theta equals to sine inverse -1 over 2, and I got it -30 degree. So I won't straight away key in this -30 degree as my final answer because I'm yet to take into consideration of the range. So for sine to qualify as negative, it will only appear at the 3rd and the 4th quadrant. So the value, okay, let's say I draw this red line here, from 180, you actually need to add 30 to reach to the red line there. And for the results in the 4th quadrant, we will actually by taking 360 minus 30. So the respective results will be 210 and 330. So this is the things that you need to take note here. By keying your results of sine inverse -1 over 2, you've gotten -30, right? This -30 is not fixed. Okay, why do I say it is not fixed here is that you have to run your own analysis, build up your own understanding and decide whether to plus or minus this value so that you can accurately identify your final answer. So for the same type of question, I added some twists. So now you will notice that I actually change up the range. So this front part is all the same. You should get this 210 and 330 results here without any issue. So here comes the negative range. So whatever that we have in the positive range is actually going through anti-clockwise. So start from 1st quadrant, 2nd, 3rd and 4th. This is anti-clockwise here. However, if for the -360 range, okay, the answer will still appear at the 3rd and the 4th quadrant, just that the direction, okay, the starting red line there, we are now going downwards or clockwise. So to get these results, our -30 will now qualify. So you only have negative results when your range actually is negative. So our first answer here will be -30 degree followed by -180 plus 30 degree. So you will get -150. So I wouldn't do -180 minus 30 again because by doing so, the answer will now appear at the second quadrant instead of the third one. I hope you understand this. If you couldn't, feel free to pause and then rewatch this part first. So one additional thing to take note is that instead of giving you the range in degree, they can actually add a twist by putting radian here. So if it's 0 to 2 pi or negative 2 pi to 2 pi. So these are the things that you need to familiarize yourself with. So moving on to example here, 2 sec square x equals to 8. First thing I did was to change the sec square x into something else because I noticed that sec cannot be keyed into your calculator. So I actually changed it into 1 over cosine square x, okay, multiply with 2 equals to 8. So get rid of the 2 here, you actually get 2 over 8 equals to cosine square x. 2 over 8, after simplification, you actually get it as 1 over 4. And to get rid of the square in the cosine, you actually have to square root the value of 1 over 4. So additional things to take note, when you introduce square root into your equation, remember to put plus minus at the front. So up to here is where I stop, and then to decide where would my answer appear. So I hope that you do the same. You can let me know later on when I discuss about it. So now I run an adjustment where x equals to cosine inverse plus minus square root 1 over 4. So I key in the calculator, I got the 1 over 3 pi. So I draw out the quadrant. The answer that I estimated will actually appear in all 4 quadrants. However, it was being restricted by the range. So the range given by the question was 0 to pi only. So 0 to pi, if you don't understand what does pi value means, you can actually multiply it with 180 over pi. So this will be 0 to 180. So at the first quadrant, cosine will be our positive here. And on the second quadrant, cosine will be negative. So these two will be the answer. So the 1 over 3 pi actually represents this first line that I drew here, 0 to 1 over 3 pi. So for you to identify the second results, you actually need to take 180 minus 1 over 3 pi. But remember, 180 is in degree. So after the conversion into pi, you should get pi minus 1 over 3 pi. So our answer will be 2 over 3 pi. For the same question, you can actually solve it with other method, because from the formula table that we have earlier, sec square x can actually be written as tangent square x plus 1. So multiply the 2 into the bracket, shift the 2 away, then I gotten 2 tangent square x equals to 8 minus 2. I get rid of the 2 by taking 6 divided by 2. So your tangent square x is now 3 here. So same thing for square, we cannot key into the calculator. So I introduce a square root here. So tangent x equals to plus minus square root 3. So the answer will still be appearing at the first and second quadrant only due to the restriction on the range. So at the first quadrant is where tangent is positive because it is all. Then at the second quadrant will be where tangent is negative. So if you're confused, why do I know the value on the other side is also 1 over 3 pi? You must pause this video now and go back to the mathematics version first, because there is where I explain on the concept on using vertically opposite as well as the reflection method. Watch that, then head back to here. So moving on to example 2, we have 2 over sine theta equals to 1 plus 3 sine theta. So This example 2 here will cover how algebra, the factorizations, mix up with this topic here. So the first thing that I did was to cross multiply them. So I have to put a over 1 underneath the 1 plus 3 sine theta. By doing so, after the cross multiplication, I gotten sine theta plus sine squared theta equals to 2. So you rearrange everything into the format where the one with square at the front, the one without square at the center, the one without unknown at the last, and then equals to 0. So the unknown here is actually our sine theta. After you run the factorization process, so if you couldn't do this, you can actually set sine theta equals to x, then you have 3x squared plus x minus 2. So you can actually understand better by swapping out the x into something else first, then later on substitute it back. So for me, I won't be doing that because some of you might find it confusing, but it is an option for you. So after the factorization, you should get 3 sine theta minus 2 multiply with sine theta plus 1. And this will be equals to 0. So I run some adjustment, so I get 3 sine theta equals to 2, sine theta equals to 2 over 3, or sine theta equals to negative 1. So with this being said, I know that my answer will appear at first and second quadrant for the one that is positive. And for the one that's negative, which is our sine theta equals to negative 1 here, it could appear at the third and fourth quadrant. So after analyzing that, I then key in sine inverse 2 over 3 or sine inverse negative 1. So by keying into a calculator, you will get your results as 41.8, and for the second result, it will be 180 minus 41.8, which is 138.2. So the next answer, okay, like what I expected earlier before keying to a calculator, you should have 4 results because your answer could appear at all 4 quadrants. However, when I key in my sine inverse negative 1, I actually gotten negative 90 degree. So if it's negative 90 degree, means that from 0 degree, I going clockwise by 90. So it's arriving at here, this red line over here. So for me to get the answer, I should actually take 360 minus 90 degree. So the answer will be 270 degree. So things to take note is your answer will only appear to be negative provided your range covers it. If it doesn't, means that you have to go through the anti-clockwise way to identify the exact value. So moving on, for the same question, I adjusted the range into negative 360 to 0. So whatever that I did earlier was the same, the factorization process, everything is the same up till here, where I'm identifying the first and second quadrant value. So like what we did, after keying in, I actually get 41.8 earlier, right? However, this 41.8 won't be accepted here because it is beyond the range of 0. So instead of doing this, we have to go through the anti-clockwise way. So we have negative 360, you add it with 41.8, then you get 318.2 for us to identify the first red line there. Then the next one, we will be taking negative 180 minus another 41.8. Then you will get your result as negative 221.8. As for the sine inverse negative 1, by keying to the calculator, earlier we got a negative 90, right? So this time around, no changes is needed because it falls right within the range. So you just key in negative 90 as your final answer. Moving on to example 3 here, it is a combination of our part 1 where it involves substitution and our part 2 where it involves factorization. So a combo of both will form the third type of question where you actually need to run some conversion, then only factorize it. So the first question that we have here is sine x multiplied with cosine x equals to 1 over 2 tangent x. And the range given to us is 0 to 2 pi. So if you notice on the previous question, you might get a different answer compared to mine because you might not pay attention to the range. The range actually is an indication on what mode should you put your calculator in, whether it is radian mode or degree mode. So how to determine that is by checking the range. So if you saw pi in the range or you saw decimals like 0 point something or 1 point something without the degree sign, means that you need to set your calculator into radian mode to accurately identify what's your final answer. So take note on that. And because of the previous question is in degree mode, okay, the last question that I covered in type 2, so over here I have to change my calculator mode into radian in order to identify the final value. So I run some adjustment on the tangent x, then I gotten it as sine x over cosine x. Multiply it with 1 over 2 and then cross multiply them. You should get 2 sine x cosine square x equals to sine x. Bring your sine x over, okay, extract the common variables. So this 2 here has one thing in common, which is our sine x. After extracting it out, you have bracket 2 cosine square x minus 1 equals to 0. So with this, you know your sine x equals to 0 or your cosine square x equals to 1 over 2. So if you couldn't understand this, basically what you need to do now is to imagine this question as maybe I change my sine x into x, I change my cosine square x into y. So maybe you have 2x y square minus x. Both things, x is repeating, so you extracted it out. So the balance inside the bracket will be 2y square minus 1, and you compare it to 0. So back to the end of the day, whatever that you learn on Addmath still need your solid foundation in your mathematics. So now go back to the question. So we have sine x equals to 0. 0 is not negative or positive. Okay, but since it's not negative, I roughly assume that my answer could appear at the first and second quadrant. By keying sine inverse 0 into a calculator, I gotten it as 0 and then reflect it, then I gotten pi. The reason why I still include 0 here as one of the answer is that you have to look at the inequality symbol used at the range part. Over at the inequality symbol, it was more than equals to 0. So this is the reason why I can accept 0 as one of my answer here. Moving on to the next one. As for our cosine square x equals to 1 over 2, I get rid of the square by introducing square root. Plus minus 1 over 2. So with this, I know my cosine results could appear in all 4 quadrants. When you key in cosine inverse square root 1 over 2, you should get 1 over 4 pi. When you key in negative square root 1 over 2, you will get 3 over 4 pi. So I won't write the exact answer yet because I know that I actually have 4 results located on all 4 quadrants. So the first line here at the first quadrant will actually have a value of 1 over 4 pi. So for cosine to be positive, it will also appear at the 4th quadrant. So for us to identify the results from the 4th quadrant, I will be taking 2 pi minus 1 over 4 pi. So I got the results as 7 over 4 pi. Moving on, we have the next answer, okay, which is for cosine inverse negative square root of 1 over 2. So for this, I know that it is 3 over 4 pi, and to identify the results in the third quadrant, I will be taking 2 pi minus 3 over 4 pi. So that's how you identify the final value. Moving on to the next question, we have 6 sine square x minus 13 cosine x equals to 1. So this thing here, okay, first thing that I did was to run the substitution where sine square x can actually be written as 1 minus cosine square x. So I multiply the 6 into it, run the arrangement. You should get negative 6 cosine square x minus 13 cosine x plus 5 equals to 0. However, because of my own personal preference, I don't like my equation to be negative. So I actually run some adjustment, multiply everything by negative. Then I gotten 6 cosine square x plus cosine x minus 5. It's just a personal preference here. If you understand the negative concept, you can just proceed with it. But I don't want to confuse myself because the paper, after you solve a lot of questions, is already very tiring already. So I wanted to eliminate that mistake. So I convert everything into positive instead. So I run the factorization, I gotten 2 cosine x plus 5 and 3 cosine x minus 1. Run the adjustment, then you get cosine x equals to negative 5 over 2 and cosine x equals to 1 over 3. By reaching at this step, you know that you have negative results and positive results, which means all 4 quadrants could actually have answer. So if it's a negative, means that your answer will be appearing at the second and third quadrant. And if it's positive, means that your answer will appear at the first and fourth quadrant. However, after keying in cosine inverse negative 5 over 2 into my calculator, I got a math error. So I know that this is actually invalid. So I can move on and to only focus at the cosine inverse 1 over 3. So by keying to your calculator, you will get this result as 1.23 radian. So one thing to take note here is that if your answer cannot be written in pi form, please take 3 significant figures and put radian at the back of it to indicate what's the value. So x will actually be 1.23 radian, and to identify the fourth quadrant results, I will be taking 2 pi minus 1.23. So your answer for that will be 5.05 radian. So the last example here will be example 4. Example 4 is actually the hardest among all because there's changes to the range that you need to apply. Whatever from the front is only factorization and substitution or a combination of both. The fourth part is the hardest because you actually need to adjust the range as well. So let's go through the example that we have here. So the first one, we have 2 cosine 2x equals to square root 3. So this thing here, you will now notice instead of the usual theta or x only, now they change it into 2x, which means you actually need to identify your new range first. The range given to us was 0 to pi. After multiplying it by 2, you should get 0 to 2 pi. So this is our new range here. So I can now move on and get rid of the 2. So cosine 2x equals to square root 3 over 2. This result here tells me that my cosine is actually positive. So for cosine to be positive, I will have answer at my first and the fourth quadrant. Originally, if you didn't change the range, it will tell us that we only have one answer at the first quadrant. However, after changing it, so fourth quadrant results is also included because our range was extended from 0 to 2 pi. So now you key in cosine inverse square root 3 over 2 into your calculator, then you should get 1 over 6 pi first. So this 1 over 6 pi is actually our first quadrant results. So to identify the fourth quadrant results, we'll be taking 2 pi minus 1 over 6 pi. So the final answer for that will be 11 over 6 pi. So do take note that this results that we gotten is for 2x. For you to identify x answer, you actually have to divide everything by 2. So your final answer for this will be 1 over 12 pi and 11 over 12 pi. So this is the easier version where they changes the range. So moving on, we have another one, which is they add or minus something here. So we have negative 2 tangent 3x minus 4 equals to 1. So this is really tricky here because you have to multiply everything by 3, then minus it with 4. So after multiplying everything by 3 and minus by 4, I gotten my range from negative 4 to 0.712. So this is where your conversion kicks in. So if you couldn't understand what does this value means, it's best you convert it into degree first and roughly plot out where's the range started from and where does it covers. After having the new range, I run the arrangement where I shift the negative 2 away. So I know my 3x minus 4 equals to tangent inverse negative 1 over 2. So for tangent to qualify as a negative, you will have results at this second and the fourth quadrant. After I plot this out, I'll be checking the range that was given to us. The range that we have here is actually 0 to 0.712 is the results in the first quadrant. Okay, they will accept any results that fall within the range. And then the other one is going by clockwise with a negative 4. So now I know that my answer is falling at the second and fourth quadrant. So I know that both of them will actually be in negative because it's from the negative range. Nothing will appear in the positive one. So after I key in tangent inverse bracket negative 1 over 2, I gotten negative 0.464. So this will be our first results here. And for us to identify the next one, I will be taking negative pi minus 0.464, then I gotten negative 3.61. So this negative 3.61 still fall within the range because our range is from 0.712 until negative 4. So it didn't exceed the negative 4, so it will be accepted. So now the basic part, get rid of the negative 4 by shifting it away. So everything must be added by 4 and then divided by 3. So your final answer for this will be 0.131 and 1.18. So remember to put everything in 3 significant figures. So this part may sound a bit confusing. Feel free to pause it, relook into the workings. So over here at the last example, we have 2 sine square bracket x plus pi over 3 equals to 1. So first thing that I did was to adjust the range first. So now we will have x plus pi over 3, then you have pi over 3 to 7 over 3 pi. So I move on, get rid of the 2, get rid of the square by introducing square root. Okay, remember to put the plus minus. So this basically tells me that I would have answer in all 4 quadrants. Okay, by keying your calculator, sine inverse square root plus minus 1 over 2, you actually get 1 over 4 pi. But I wouldn't, like what I said earlier, I wouldn't take it as the final results because I'm yet to analyze the range given to us. So the range tells us that pi over 3, okay, is this one over here. Pi over 3 is actually 60 after the conversion. And it ends at 7 pi over 3. So this is actually 420 degrees. So this answer here, our 1 over 4 pi, you have to ask yourself whether it falls within the range or not. So from where we started, it's actually pi over 3, which means that our pi over 4 will not be accepted because it doesn't fall within the range that we start. So I will move on to identify the results in the second quadrant first. So I'll be taking pi minus pi 1 over 4 pi, and our third quadrant results will be pi plus 1 over 4 pi, and our fourth quadrant results will be taking 2 pi minus 1 over 4 pi. And the last one, okay, I should take 2 pi plus 1 over 4 pi because our range has been extended until 7 over 3 pi, and this 7 over 3 pi is actually 420. So by taking 360, which is our 2 pi here, add it with 1 over 4 pi, 1 over 4 pi value is actually 45 degrees. So by adding it, it still falls within the range, so it does qualify as another answer. So I run the calculation, I got an x plus pi over 3 equals to 3 over 4 pi, 5 over 4 pi, 7 over 4 pi, and 9 over 4 pi. Minus everything by pi over 3, then you'll be able to get your final results as 5 over 12 pi, 11 over 12 pi, 17 over 12 pi, and also 23 over 12 pi. So this is pretty much how they will test you out in your exam. So feel free to watch it. You can download the slide that is in the description box. Revisit this question, do it on a paper by yourself, and check whether you get the same answer as mine. So do take note on this. All the little things that add up. Remember, if you introduce square root, you have to put plus minus. The answer that you've gotten, do not take it as your final answer straight away. You still have to run your analysis against the range given. Remember to always change your calculator mode. Depends on the range, whether it is radian or degree. So with these 3 things being covered, okay, you should be good to go and able to nail this topic. However, if you still have any question regarding this video here, feel free to leave your question down below and put in the timestamp so that I can answer you more accurately. So I hope you learned something from this video. If you have friends that are struggling on this topic, feel free to share this to them, and I wish you all the best in your upcoming examination. Thank you.